Alright, let's look at the ODE Practice Exam 4, problem number 13. Alright, so let's find the coefficient C2, C3, C4, C5. Alright, as usual, these initial condition gives us C0 value here. C0 is 1. Alright, so y prime of 0 equals 1 gives us C1 equals 1, right? All right, so let's look at the differential equation here. So here we're going to have, so you have a quantity 1 plus x squared times, right, y prime, so it's going to be a summation, n goes from 2 to infinity, n times n minus 1 times Cn x to the n minus 2, right? Then here, y prime would be summation, n goes from 1 to infinity, n times Cn x to the n minus 1. All right, then you have x times summation. All right, n goes from 0 to infinity, Cn x to the n equals 0. All right, and the first thing I would do is I'm going to just distribute 1 and the x squared, so 1 to that guy and x squared to the summation, and also this x distributed there. Alright, so let's do that. So 1 times that is going to be summation, so I'm just going to copy that. 1 times the summation, n goes from 2 to infinity. Then we have n minus 1, Cn x to the n minus 2. Alright, plus you have a summation, n goes from 2 to infinity, and then you have n minus 1, Cn, then you have x to the n, just n, because you have x squared and x to the n minus 2, so you have x to the n. Alright, so the next one, I'm going to leave it as it is. So you have a summation. N goes from 1 to infinity. And n Cn x to the n minus 1. And plus summation. N goes from 0 to infinity. We have a Cn and x to the n minus 1. Alright, so this is going to be equal to 0. Alright, so the next step would be we would like to have x squared. Alright, we'd like to have x to the n everywhere. So we have to make a little bit of adjustment here. So here, I would like to have x to the n, so n minus 1. So what we can do is we can actually, I messed that up. So this is actually n plus 1. All right, then I would like to start from n here. So we would like to have an nth power here. So what we're going to do is I'm going to actually start from 1. So we can change that to 1, right? So if you change that from 1, then you would have to change the indices, decrease by 1. So it's going to be n minus 1, and then this is going to be n, right? Maybe I should write that down here. So this is going to be a summation. N starts from 1 to infinity. You have a Cn minus 1, x to the n, right? So we have that. All right, then here we have n minus 1. So what we can do is we can actually start from n equals 0, then since we decrease the starting number by 1, so we have to increase the indices by 1. So you have n plus 1 and cn plus 1, and then you have x to the n. Right? So we have x to the n there. Alright, this one we don't have to really do much, so I'm going to just copy that summation, and goes from 2 to infinity, and n minus 1 cn x to the n. We already have x to the n there. Right? Here we're going to have to do the same thing. Right? So summation, I'm going to start from 0 to infinity. Right? That way we can increase the indices by 2. So n becomes n plus 2, n minus 1 becomes n plus 1, cn becomes cn plus 2, x to the n minus 2 becomes x to the n. Alright, then we have to do something here. So some of them start from 0, some of them start from 2. So let's see, I'm going to actually try to make it start from 1. Right? So here, one thing I can do with this guy is, since when n equals 1, this guy is actually 0 anyway, so I can actually change that to 1 without doing anything. Right? Other ones we have to take care of those, so I'm going to write it this way here. So what I'm going to do is I'm going to put everyone start from 1, but there are 2 extra terms here. So you have here, this summation has n equals 0, and the third summation has n equals 0. So I'm going to pull those out. So when n equals 0 from here, so you have a 2 times 1 times c2. So it's going to be 2c2, right, plus, right, from here, you're going to have n equals 0, so it's going to be 1c1, so plus c1. Right? Then we can just, everyone starts from 1. So n starts from 1 to infinity, right? And everyone seems to have x to the n. So I'm going to put, let's see, x to the n here, right? So let's just circle these things. So you have x to the n here, x to the n here, x to the n there, x to the n there, right? Then you would have, right, we just have to collect everything. So you have n plus 2 times n plus 1, cn plus 2, and plus n times n minus 1 cn, plus n plus 1 cn plus 1, plus cn minus 1. Right? And then we set that equal to 0. Right? So first condition we get would be, we have to make sure that all the coefficient is going to be 0. So we have to make sure that this is basically a constant term, is equal to 0. And then we set all these guys right here, set that expression equals to 0. Alright, then we get this condition. First here, I'm going to actually solve for C2. So we're going to get, let's see, I'm going to do it in my head. So C2 is going to be, I put C1 on the other side, it's going to be negative C1. Then divide by 2 to isolate C2. So we get that, right? But the C1, we already know that it's 1. So this is going to be negative 1/2. Alright, and then if you solve this guy for cn plus 2, so cn plus 2 is equal to, alright, so I have to put these 3 terms on the other side, so it becomes negative, right? So this is going to be n times n minus 1 cn, and then plus n plus 1 cn plus 1, and plus Cn minus 1, right? Then you have to divide by n plus 2 and n plus 1, right? So I just isolated Cn plus 2, right? So we found, let's see, C2. So we already found C2. So here, maybe I should have, let's see, I'm going to write it this way. So here, so this tells you that we found the C2 to be negative 1/2, right? So we got that. So I'm going to just box it out so that so we have the value there. All right, then let's find C3. All right, so in order to find C3, so we just have to plug in n equals 1. All right, so you have a C3 is equal to negative. All right, n equals 1. So when n equals 1, this first term is 0. All right, so n equals 1. So 2 times C2. So we have a 2C2. All right, plus C2 minus 1. So plus C1. All right, then divide by. So put 1 here. So it's going to be 3 times 2. So that will be 6. All right, but you can see that, let's see, C2. We know that it's negative 1/2, and the C1 is 1. So it's 2 times negative 1/2 is negative 1 plus 1 is actually 0. So this will give us C3 value, which happens to be 0. All right. So we have C3 value already. All right, then we can find the C4 value by setting n equals 2. All right, so C4 is going to be negative. All right, so n equals 2, so it's a 2 times 1 C2, so it's a 2C2 again. All right, then then we put 2, so it's a 3C3 plus 3C3 and plus C1. All right, and then over, so 2, so 4 times 3, so 4 times 3, so 12. All right, then again, we know that the C2 is negative 1/2, so times 2, negative 1, and the C3 is 0, so we can just cancel that because it's 0, and the C1 is actually 1, so it's going to be, let's see, did I make a mistake? Actually this was C0, sorry, but which is 1 anyway, so C1 is going to be 1. All right, looks like we have another negative 1 plus 1, so it's actually 0 again. All right, so C4 is actually 0. All right, the last one, C5. So we set n equals, n equals 3. All right, then we can find C5, which is equal to negative. All right, so C5 is equals 3, so 3 times 2. So let's see, it's a 3 times 2, so 6 C3. All right, and then we have a 3 plus 1, so plus 4 C4. All right, plus C2. All right, then we have, let's see, 3, so 5 times 4, so it's 20. All right, but looks like C3 is 0, so that's 0. And C4 is actually also 0. All right, C2 is negative 1/2. So you can see that negative 1/2 over 20, so it's negative 1 over 40, but with the negative sign, so it's a positive 1 over 40. So we get the C5 is equal to 1 over 40. Alright, so that's the C5 value. Alright, that's it. I hope that this was clear.